We are solving question from GATE 2018. This is from electronics branch and it was of 2 marks question. So a DC current of 26 microampere is flowing through the circuit. A DC current of 26 microampere is flowing through the circuit and the diode is forward biased. So in this circuit a DC current of 26 microampere is flowing. This diode is forward biased and it has an ideality factor of 1. So and at the quiescent point the diode has a junction capacitance of 0.5 nanofarad. Then its neutral region resistance can be neglected and we have to assume that the room temperature thermal equivalent voltage is 26 millivolt. So this is obvious that Vt is 26 millivolt at room temperature. Then for omega equal to 2 into 10 to power 6 radians per second, we have to find the amplitude of small signal component of diode current. So this is based on a small signal model of diode. So for the small signal model of diode, we have to know the small signal resistance of diode. So the small signal resistance of diode Rd is given by the thermal voltage is 26 millivolt. So Vt upon the diode current. So 26 millivolt upon the diode current is given as 26 microampere. So upon 26 microampere. So this will be equal to 1000. So the small signal resistance of diode is 1000 or 1 kilo ohm. And Cj is given as 0.5 nanofarad. 0.5 nanofarad. So we can draw the small signal model of the diode. So the small signal model of diode is like this. We have to replace this diode with a resistance, forward resistance of 1000 kilo ohm, the small signal resistance, and a capacitance in parallel, junction capacitance. And for a small signal model of diode, we have to short the DC source. So we are shorting the DC source. So this resistance is 1000 ohms. And we have to find the value of this reactance. So this reactance will be given by 1 upon omega C. So it will be equal to, omega value is given to us as 2 into 10 to power 6. So 1 upon 2 into 10 to power 6 into 0.5 into 10 to power minus 9. So this will be, Xc will be equal to 1000. 1000. So this Xc is equal to 1000. So this is 1000, X is equal to 1000. So Z equivalent will be equal to 1000 plus J 1000 in parallel with J 1000 plus 100. So this will be equal to 1000 into J 1000 upon 1000 plus J 1000. So taking 1000 common, it will cancel, plus 100 as it is. So this will be equal to 1000 upon 1 plus J. 1000 upon 1 plus J, and it is J 1000. So rationalize 1 minus J upon 1 minus J plus 100. So this will give 500 minus J 500 plus 100. So 100 plus 500 will be equal to 600. 100 plus 500 will be equal to 600. So this is equal to 600 minus J 500. So Z equivalent is equal to 600 minus J 500. This is the equivalent Z equivalent. Equal to 600 minus J 500. So if we find the mod of Z equivalent, then it will be equal to under root of 600 square plus 500 square. So mod of Z equivalent will be equal to 781.02. .02 is the mod of Z equivalent. So we have to find the amplitude of a small signal component of diode. So it will be equal to V upon Z equivalent. So V is 5 sine of omega t. So its value is amplitude is 5, its maximum amplitude upon 781.02. So this will be equal to 6.04 microampere. This is the small signal component of diode current. So we found the small signal component of diode current by replacing the component with its diode with its small signal model. So in its small signal model, it will be a resistance of 1000 kilo ohm in parallel with the capacitance of 1000. The reactance of 1000. So 1000 will be in parallel with J1000. This R is 1000 and this XC is 1000. So 1000 and resistance of 1000 ohm and this reactance of 1000 are in parallel. So we found their equivalent by 1000 in parallel with J1000 plus 100. So when we found the equivalent impedance, then we took its magnitude and dividing the voltage by the magnitude of the impedance, we got the small signal component of diode current. So to get the small signal component of diode current, we had to draw the small signal model. So this was a gate question from gate 2018. So this is how we draw the small signal of model of diode and get our answer for diode current. And for a small signal model, we have to short the DC source. So please remember this. So if you have any doubts, you can message me. If you have any query also, you can message me. Also please leave feedback in the comment box. Thank you, and please like and share the video and subscribe the channel.